All right, what type of triangle are you looking at right here? This is a right triangle. Okay? A right triangle is important that you know where the hypotenuse is and its legs. It will have one hypotenuse and two legs. And how many sides does a triangle have? So if you find that hypotenuse, you know what? Whatever's left are the legs. The hypotenuse is, see this right angle sign right here? The point right there is basically always pointing at the hypotenuse. Once you find that, you then know this is a leg, that's a leg. It's that simple. And the hypotenuse is always the longest side. Pythagorean's theorem basically says you have a right triangle. The hypotenuse is C, your legs are A and B. The Pythagorean theorem says that the hypotenuse, square of the hypotenuse, is always equal to the sum of the squares of the legs. That's simple. Pythagorean triples. Are basically three numbers that fit into Pythagorean's theorem. So what does that mean? An example of a Pythagorean triple would be 3, 4, and 5. The smallest, probably most common one. Why is it a Pythagorean triple? Why do you think, guys? Fits into this. Well, how do I know which one's C? C's the biggest number, isn't it? So with that in mind, 5 squared would have to equal what? 3 squared plus what? So 25 is equal to what? 9 plus 16. Is that true? Is 25 equal to 25? That is a true statement. That's why these are what? Pythagorean triples. Because they fit into Pythagorean's theorem. That's it, and that's that. What we're going to talk about now is using Pythagorean's theorem to determine if a triangle is acute, right, or what do you think's left? Obtuse. And even though, well, and they do it how I do. What I like to do is you always got to think of this in terms of your hypotenuse, which is always your what? Largest side. Now, if I was to keep these sides exactly the same, everybody just look up here. If I was to keep these sides exactly the same length, put it there, and I was to make this angle bigger than 90, tell me what happens to the hypotenuse. Do we make it bigger or smaller? We did. And what type of triangle is that? Obtuse? If I used one the exact same length, you know, this side here, and I made it smaller, what happened to this side? It became an acute triangle, and what happened to C? It got what? So with that logic, when C squared is bigger than A squared plus B squared, when C squared is equal to A squared plus B squared, or when C squared is less than A squared plus B squared, what do you think type of triangle you have in each of these cases? Now, look here. What happened when I made the angle bigger than 90? Everybody just look up here. Please just look up here. Because you'll remember this better than you will, you know, okay, when you do this on an ACT test or an end of instruction test, if you'll understand the concept, you'll be able to work it out in your head. Really? Why don't you put that on my desk? You'll be able to work it out better than, you know, trying to, okay, which one was it? Was obtuse less than? Was it, you know, greater than? Which one is it? Just think about it. Okay, what happened to the angle when C got bigger?
It got bigger?
The angle got bigger, right? So what, and it made what type of triangle? So when C squared's bigger than A squared plus B squared, what do you think is going to happen? It's going to be
Obtuse.
obtuse. Because that hypotenuse had to get bigger because the angle got bigger, right? So at the same time, when that C squared gets smaller than A squared plus B squared, what do you think's happening to that angle? It's getting
Smaller.
so making this one what?
Acute.
Very good. What about when it's exactly equal? So now, conceivably, I should be able to pick three numbers for the sides of a triangle and say, hey, is that an acute, obtuse, or right triangle? You can plug them in and see. It all has to do with the largest side. Is it bigger? Is the square bigger than the sum of the other two squares? Is it equal to the sum of the other two squares? Or is it what? Less than the sum of the other two squares. That's your test. So, since we're on that, let's look at some from our workbooks, and we'll kind of, I'll write them on here, but we'll, what, 8.2, let's see. Let's look at number 13, page 99, number 13. They want to know whether it's what? Acute. We have one of 7, 24, and what? 25. They want to know if that's acute, right, or obtuse. And they want you to justify your answer. I justify my answer by plugging it in and seeing how. Right now, though, what always when dealing with triangles or right triangles, what are you going to find first? The C, right? The big one. So what do I have to see? I have to see how what? 25 what? Squared relates to what? 7 squared plus what? What is 25 squared? Because we're going to have some sign here. It's either going to be equal, greater than, or less than, isn't it? What is 25 squared? 625. And what's this? 49 plus, what's 24 squared? 500 what?
76.
What do you get here? What's,
625,
you get 625?
yeah.
So what kind is this? They are equal, so it is a right triangle. That's not too bad at all, is it? What happens is people try to memorize that instead of understanding. I mean, isn't that concept pretty simple? As that angle gets bigger, it's going to what? Make that side get bigger. So obviously when c squared's bigger than the square of the other two, added together, then it's obtuse. When it gets smaller than equal, it's what? Acute. So and the other one is 8, 14. This is number 14, is it? And 20. Probably made that too big. We don't hardly have enough room. But so I'd see what? How does 20 squared relate to what? 8 squared plus what? 14 squared. I get 400. What is this? 64 plus, what's 14 squared? So I have 400. How does it relate to, what do I get? 260? Is that correct? What is it? 400's bigger, isn't it? So what is this? Now, how did I justify my answer? Do I need to write some words? No. You justified it by what? You know, doing this. These 3 steps. It's not the end of the world if you go from here to here and here to here, but I need to see that. Are we understood? And I need to see this inequality written. You tell me, I said 625 is equal to 625, so that's why it's a. Here, I said that 400 is greater than 260. I need to see where you started, where you ended up. I'm fine with you doing this step in your calculator, but for notes, I want to, you know, do every step so you guys can see it. Okay? Make sense? Think we got that down? That's pretty easy, isn't it? Okay. Now, let's go over to that same page and let's solve some, you know, you guys all should have solved some of these before. First of all, with this one, number 1. To solve this, what do? I need to first find the what? Tell me what to find first, guys. The hypotenuse. What is the hypotenuse? Remember, that thing's always kind of pointing at it, isn't it? So x what? Squared is equal to what? 9 squared plus what? Remember this, though. You can only solve for the third side when it's a right triangle. When it's an acute or obtuse triangle, I can only say what, you know, if there was an unknown there, I could just solve for that and say what, you know, what it might be less than or greater than. Okay? Now, so x squared is equal to, what is 9 squared? So this is 81, and this is what, 144? When you add them together, what do you get? Huh?
225.
X is equal to? Now, they just said find x, didn't they? When they say just find x, I want you to assume they want it in simplest radical form, unless you have what under the square root? A decimal. If you have a decimal, then you can round it and all that stuff, but we're going to leave our answers in simplest radical form. Try number 2. What is my equation?
13 squared.
Yep, that's pointing right at that hypotenuse. So 13 squared is equal to x squared plus 12 squared. 169 is equal to x squared plus 144. X squared is equal to what? 25? Don't forget to take the square root. X is equal to 5. I don't know what I don't know, want to know what x squared is equal to. I want to know what x is equal to. Well, doggone it. I wish they'd give me one that wouldn't come out even every time. Let's jump to number 5. How are they trying to trick you here? If this is 9, this is 9, this is an altitude, what's this going to do to this one? Cut it in? So really, what is your right triangle that you're going to kind of deal with and make your, but that use Pythagorean's theorem with? Is it that one? This one right here, or the other one? So what is my equation?
9 squared plus.
Is equal to.
Equal to x squared.
Plus 4 squared.
So I've got 81 is equal to x squared plus what? 16? X squared is equal to 65. Is that correct? That may be simplified. Your answer is square root of 65. We good on this? What does Canvas say? You guys looked at it yet? One through 18, 21 through 26. Write problems, draw figures, show all steps, and work. You think I'm going to be okay with you not showing the Pythagorean theorem? Probably not. Let's get to work.